And we're back. Welcome back, everybody. Don't forget to subscribe. I'm almost at 100 subscribers. Yeah? 100 subscribers special. Okay, so section 5.5, day 2. Now, just so you guys know, tomorrow is going to be a practice test work day. I'm going to give you the practice test for the first half of chapter 5, sections 5.1 to 5.5. Work day tomorrow. Go over it Thursday. Sections 5.1 to 5.5 test on Friday. Sound good? Okay. Now, this second day of direct variation is really just 2 examples. Look, right here, just 2 examples. That's all we have to get through. One is about word problems. The other one's a little bit more about graphing. Let's take a look at this first word problem example. A group of people are tubing down a river at an average speed of 2 miles per hour. Write a direct variation equation that gives the number of miles y that the people will float in X hours. Guys, I didn't really even need to tell you it was a direct variation. Because if I just said, I'm floating down a river at an average speed of 2, what would the equation be? Oh, and the phone rings. I bet it's saying, can you send down directly? Hi, Mrs. Brown. I'm doing well. How are you doing? He's on his way. No problem. Told you. All right, so what would be my equation if I said, okay, we're floating down a river at an average speed of 2? What would be the equation? What do we think? Mr. Anderson? What's that? Y equals 2x. Now we have the capability of saying, oh, that's a direct variation. Y is equal to 2 times x, where x is the amount of hours and y is the amount of miles. I'm in the river 1 hour, I go 2 miles. I go 2 hours, I go 4 miles. So that's what we're looking at here. This is a direct variation. Now, we're going to plot some points here, giving us a reasonable domain, and we're going to try to analyze the graph a little bit. Now, what's my first value in a reasonable domain? Give me my first value. 0. 0. Why don't I want negatives? Right, you can't go into negative time, you can't go negative miles. I'm only going to stay within the first quadrant anyway. I mean, you can have a bad time, but you can't have negative time. Yeah, thanks for the courtesy that. So let's start at 0. Let's start at 0. Let's go 0, 1, 2, 3. Okay. If I'm at 0 hours, how far have I moved? 0 miles. 1 hour? 2 hours? 3? Now, here's what we can say. Look at the y values. How much are they going up by? What's my k value? See those match. What's my slope going to be? Right? All of those values are going to be the same. Okay? Let's graph this now. So just make yourself a graph. Don't forget to label your axes. This is hours, and this is miles. Looks like I'm going up by ones. Each place is going to be fine. 0, comma 0, 1, comma 2, 2, comma 4, 3, comma 6. If I wanted to, I could say 4, comma 8. Now, do I go down past my axis? Start here, on upward. So there's my graph. I mean, I could have done that like 2 weeks ago, right? And back in chapter 4 if I really wanted to. But now we know that this equation is represented by a direct variation. And now we can talk about it in a little bit of a different way. Here's the other thing that I wanted to show you. Let me ask you this, guys. If I have y is equal to kx, and I wanted to, we know this is every direct variation is y is equal to kx. If it's not in this form, it's not a direct variation. Done. Okay, what would happen if I plugged in 0? Even if I didn't know what k really was, because k is just a number. What would happen if I plugged in 0? I would always get 0, right? Because this would be y is equal to k times 0, and anything times 0 is 0. I just made a pretty powerful statement right there. I said that whenever you have a direct variation, if you plug in 0, you get out 0, which means that every direct variation will run through the origin, will run through 0, 0. Every single direct variation will run through the origin. There are no exceptions to that rule. If it's a direct variation, it's going to run through the origin. If it's not a direct variation, it's not going to run through the origin. Okay? So let's take a look here. What if I tell you that this ordered pair lies on a line that's a direct variation? Well, if that's the case, I can graph the line, I can find the equation, I can do all that stuff quite easily. Go ahead and write this down with me. You don't have to write down the whole premise, you're just writing down the fact that this is direct variation, and it's through 0.3 comma negative amount. Now, if I wanted to write the equation, y is equal to kx, don't I need the k value? Yeah. Isn't the k value pretty easy to find? Take y divided by x. Negative 9 over 3. Negative 3. So I know my equation is y is equal to negative 3x. Simple as that. Now I graph my line. Now, in the tubing down the river problem, I had to graph several points. Guess what? I don't need to do that anymore. What point is that going to run through? 0, 0. What point was given to me? 3, negative 9. 3, negative 9. Don't 2 points make a line? And there's my line. I didn't even need to make a table. Could I use this to verify the slope is the k value? Look, down 3, right 1. Down 3, right 1. Down 3, up 3, left 1. Up 3, left 1. Man, I did a pretty good job of drawing that line. So, slope is the k value, right? Every direct variation is going to run through 0, 0. And if I give you a coordinate, you can just plot that coordinate, run it through 0, 0. There's your line. As long as it's a direct variation. Let's do one more of those. First off, write the equation. Never give me a k value that's a decimal. Unless it's a little problem. So the k value here, again, is y over x. Okay, again, negative 2/5. Please don't say 0.4. Don't say 0.4. Or I wouldn't say negative. I would say positive 0.4 anyway, because it's negative 0.4. But don't give me a decimal. Leave it as a fraction. Leave it as a fraction, because it's technically slope, right? So my equation is y is equal to negative 2/5 x. Y is equal to negative 2/5 x. Now, it runs through 0, 0. Which other point does it run through? Negative 5 comma 2. Okay. There's my line. Kind of on the high side of the line, but it's okay. Pretty simple as that, right? Questions about any of that? You good? All right. So long, folks playing along at home. We'll see you later. Adios.